All right, here's notes for 8.5, using properties of trapezoids and kites. Full page of definitions to start us out with, and we just want to make sure we're clear on what each of these shapes are, and then we'll learn more properties after the definition. So one quadrilateral, remember all these are four-sided figures, that we're talking about is the trapezoid. And it's a quadrilateral, four sides with exactly, and this is so important, one pair of parallel sides. Okay, one pair of parallel sides. You might see a trapezoid that looks like this. This and this is parallel, all the rest are not. So there has to be only one pair of parallel sides, and that makes it a trapezoid, okay? I purposely drew this last picture like this because sometimes people don't see that as a trapezoid. The picture below here, this is what people often visualize as the trapezoid, but remember the rule is one pair of parallel sides. So because of that, the one I drew up top there, that is a a quadrilateral, because it has one pair of parallel sides. Okay, the bases of the trapezoid are those parallel sides. We call this one like base 1, we call this one base 2, or we can flip those names. They don't have to be specific, but they are different bases. And what's super, super important to realize is they will never be congruent, okay? They will never be the same length on a trapezoid. Those bases are always different lengths, or it wouldn't be a trapezoid, okay? Then we have base angles of a trapezoid. These are there's two pairs, okay? And what's important is it's an angle between a base and a leg. So this up here touches this base, and the other one that also touches that base, those two are a pair of base angles. Okay, so we need to remember that the ones that touch the same base. So likewise, down here on the bottom, this one over here touches this base. So this one over here also touches this base, and those are also a pair of base angles, okay? Quick note, I was a little bit careful there in how I marked my angles. Do you notice how I have a different number of arcs in each one of them? There's a high possibility in a picture of a trapezoid that all four angles are different measures. We haven't seen that with our parallelogram rules because we knew opposite angles were congruent and all this stuff, but I want you to understand in a trapezoid, all four angles can be different, okay? The one thing we know for sure about those four angles, they have to add up to 360 because it is a quadrilateral, so all angles add up to 360. That's about the only thing that's certain on those angles in a trapezoid, but all four can be different measures, okay? All right, the legs of a trapezoid, the non-parallel side, okay? So we have these legs here, I have a leg here, and I have a leg here, okay? So those are the legs, and again, you'll notice by the way I marked them, they might be congruent, they may not be congruent, okay? So that's one thing I want you to know is they may or may not be congruent, okay? So just keep that in mind as we do those. The legs can be, but they don't have to be congruent, okay? And bases will never be congruent. All right, so we get to an isosceles trapezoid, the trapezoid where the legs are congruent, okay? Remember isosceles, when we had isosceles triangles, there were two sides congruent. So when we have isosceles trapezoid, there's two sides congruent, and it's the legs, okay? So you'll often see it drawn something like this, and you'll see those marks right there. The bases still will never be congruent, but the legs can be, and if they are, we call it an isosceles trapezoid. Okay. Next definition, and this is a big one for us, we're going to have a full theorem and practice problems on it and such like that, is the mid-segment of a trapezoid. This is the segment that connects the midpoints. So if we find the midpoint, the point that's middle on this leg, and the point that's middle on this leg, and we join those, that's called the mid-segment of a trapezoid. I want to remind you, when we had a triangle and we found mid-segments, we found the midpoint on one side and the midpoint on another side, and we joined it. And the midpoint of the other side, and we join those, okay? Joining the midpoints of sides. It's the same idea here in a trapezoid, only we don't do the bases, we just do the legs. We find their midpoints and join them, and that's the mid-segment of a trapezoid, okay? So very similar to the definition of a mid-segment of a triangle, only we only do the two legs when we do the trapezoid. All right, last one is a kite. A quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. And I hope you notice that I underlined and I made that bold. Opposite sides will never be congruent, okay? Which is very, very different than our parallelogram rules. So two pairs of consecutive sides. Remember, consecutive means one right after the other. So you'll notice like on the left here, two that are side by side are congruent, and then these two that are side by side or touch are congruent, okay? But the biggest idea is opposite sides cannot be congruent. So all of our squares and rhombuses and stuff, a lot of people want to think that a rhombus looks a lot like a kite, but it has completely different rules. And one of the biggest rules that they have different is on a kite, opposite sides cannot be congruent. But on a rhombus, they definitely are because all sides are congruent. So different rules here for this kite with these consecutive sides congruent, but not opposite sides congruent. All right, so let's dig into these. Let's find some numbers that go with these and properties that go with these. So page 2, show that this figure right here is a trapezoid, okay? So I have D at 1, 3, E at 4, 4, F at 6, 2, and C at 0, 0. So how can I show something as a trapezoid? Well, I reminded you in the margin over here, what we need to have is one pair of parallel sides. Well, what shows if things are parallel or not? Slope, okay? That's what we need. We need to find slope, and then we can go from there. So a quick reminder, if you want to do the formula for slope formula, you take the second y minus the first y on top of the second x minus the first x. That's one way to do it if you want to do it mathematically. Or we can count it, and if we count up, it's positive. If we count down, it's negative. Always rise on top, run on the bottom. If we count to the right, it's positive. If we count to the left, it's negative. So I'm going to start here with DE, and I'm going to go from D to E, and I'm going to count that, okay? So I count up 1. Then I'm going to go over 1, 2, 3, and that was to the right 3. Okay, up 1 is positive 1, right 3 is positive 3. I can't reduce it. There's my slope of DE. All right, they're saying let's look at the opposite side and see what its slope is. So I'm at C down here, and I'm at F, and I'm going to count that slope. So I like to start at the bottom left when I can. So I count up 2 till I'm lined up with the other one. And then I count over 1, 2, 3, 4, 5, 6. And I went to the right, so right 6. That's a positive 2, positive 6, and that reduces when I divide by 2 to 1/3. Okay, I have equal slopes there. So because I have equal slopes, I know those two are parallel. Okay, I have 2 more sides, though I have to check because I can't just find a pair of parallel sides. I need to make sure the other pair are not parallel, because if they are, I'm back to a parallelogram. So I really need to make sure I check the opposite 2 sides as well and double check those. So I'm going to do EF over here. So again, I like to start at the bottom. I count up 2. And then notice I go left 2. So up is positive, left is negative, and I can divide by 2 on both of those. I'm going to get -1 for that slope. Okay, CD. So I'm going to count from C to D. I count up 1, 2, 3, and I count to the right 1. So up 3, right 1, they're both positive. I get a slope of 3. Okay, these two are definitely not parallel. So E and F are not the same, but EF is, I'm trying to figure out what this is. So EF is not parallel to CD, if that's what you're filling in. So because CDEF has exactly one pair of parallel sides, it is a trapezoid. So it's important to check all 4 slopes, not just 2 of them. Okay, so let's go over some theorems now that go to these trapezoids. And one thing you're going to notice right now, everything in these theorems, we are talking about an isosceles trapezoid. So it's super important to realize this is not for all trapezoids, but only if my trapezoid is isosceles, okay? I do want to mention one thing, though, in the margin here. I don't know that the notes really state this super well, but I just want us to just think about a trapezoid in general, okay? So a trapezoid has 2 sides that are parallel, and then it has 2 other sides, okay? So if I tell you this angle down here is 100, I need to be able to find this angle up here, okay? So quick reminder, okay? Yeah, I want to do a different color so you see this. Remember parallel lines? A line cuts through. If these are parallel, if you know this angle, how can you find this angle? In fact, what do we call those? Those are consecutive interior angles. And when our consecutive interior angles are between two parallel lines, they are supplementary, right? They add up to 180, okay? So one of the key things I do want you to know, and this is true for every trapezoid no matter what, in between the two parallel lines, you end up with consecutive interior angles. So the two together will add up to 180 every time between the two that touch different parallel lines but touch the same leg. So if this is 100 down here, this is 80, okay? So kind of going along, I'm just making up numbers for you. Let me tell you that this one, let's say this is, oh, that's looking kind of, actually, I'm completely not drawing a scale, so I don't even know what I'm trying to pretend here at all. Let me tell you that if that one's 75, okay? Once again, these two right here, between two parallel lines, they're going to need to add up to 180. So once again, I can take 180 and subtract that, and I'm going to get 105 down here. So I kind of stated it before, but I want to show you that in that trapezoid, following parallel line rules, you can have 4 different measurements for those angles. But the important thing to know is when I add all those together, they will always equal 360, okay? But I want you to realize that we have these parallel line rules that come way back from chapter 3 that still are true when we go to a trapezoid with a pair of parallel sides. Okay, so let's go back to these theorems now. So this, the one in the margin there is for all trapezoids, okay? So this is for all trapezoids no matter what. Now, everything in these theorems are about these isosceles trapezoids, where the legs are congruent. So if a trapezoid is isosceles, then each pair of base angles is going to be congruent, okay? So again, this is that if I know that these are the same length, then base angles are congruent. So the bottom two that touch the same base, okay, that's important. A and D will be the same measure, and then B and C that touch the same base, those will also be congruent. So make sure we realize it's the ones that touch the same base, okay? Which is a little different than we think of. So guys, by the way, if you know they're isosceles, then we also know that these two right here equal 180, right? So on an isosceles trapezoid, I could tell you 1, and you could fill in all 4. But on the one in the margin, I had to give you 2 of them, or else you didn't know how to find the rest, because that's the only thing we have to work with is the parallel lines, okay? All right, next one. If a trapezoid has a pair of congruent base angles, then it's going to be isosceles. So this is saying they didn't tell you anything about the legs, but if they told you, oh, look, A and D are the same, then you have to say, oh, then my legs have to be the same, AB has to be congruent to CD, and then I'm going to have isosceles. By the way, they could have also told you, if they give you this trapezoid and they tell you the top ones are equal, then you can also say, well, then the legs are equal, and the bottom ones have to be equal. Okay, so if one pair is congruent, then the other pair will also be congruent to itself, and those legs will be congruent, and it's isosceles. All right, the last one here, if a trapezoid is isosceles, if and only if its diagonals are congruent. Okay, so when I go from B to D here, it's going to be the exact same length from A to C. Okay, and this is so important to remember. There's only congruent diagonals in an isosceles trapezoid. It does not happen in a regular trapezoid, but it can in an isosceles, or it does in an isosceles, okay? So the only other shape we've had, I shouldn't say only other, the shape we've had that has congruent diagonals so far were rectangles, which also mean the squares do. And that's true for every rectangle and square no matter what. But only isosceles trapezoids have congruent diagonals. All right, let's move on. Third page. So here we have this shelf fitting into the corner of a kitchen. It's an isosceles trapezoid. I'm sure you all have isosceles trapezoid shelves in your kitchen, right? I mean, common thing. If not, go check. Maybe you just didn't realize that's what it was called. All right, so here we have this shelf. The top and bottom are definitely parallel. One base is definitely shorter than the other, which is always true on a trapezoid. And they give us angle K down here, and they want us to find all the rest of the angles. And this is possible on an isosceles trapezoid. So Notice my isosceles trapezoid, my legs are the same there. Okay, so KLM is isosceles, right? Which means that N and K here are base angles. And when it's isosceles, we know base angles are congruent, so that means if K is 50, N also has to be 50. Okay, so base angles are congruent. Easy to find out when it's isosceles. If it's not isosceles, we can't do it. Okay, now they want us all to also to follow L and M, or find L and M, I should say. Okay, remember, parallel lines. As soon as we have parallel lines, the two angles inside together are supplementary consecutive interior angles. So we know that those are going to add up to 180 because they are supplementary, right? Trying to fill these in as much as possible. So to find angle L, we're going to take the 180 minus that 50 we already know, and we find out that that angle L up there is 130 degrees. And then, once again, we can use our base angles because M and L are pair of base angles. They're going to be congruent, so M and L are the same, and that's also going to be 130. Okay, so we get angles that touch the same leg are supplementary. Angles that touch the same base in an isosceles trapezoid are congruent. Okay, so angle N up there was 50 degrees, angle L up there was 130, and angle M was 130. Using our different properties here. So, quick reminder again, on a trapezoid, if it's isosceles, base angles are the same. Okay, so base angles, those that touch the same angle, are going to be the same. And angles between our parallel lines will add up to 180. Okay, so that's a quick reminder on isosceles trapezoids, how to find the angles. All right, moving on to number 1 down here. It says in example 1, and if you look back, that was on the second page of notes. They drew that picture, okay? So I'm actually going to try to sketch this one because I think it's going to be easier to have the graph. Everything's first quadrant. So 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7. I think that's enough. Okay, D is at 1, 3 this time. C is at 0, 0. F is at 6, 2, 1, 2, 3, 4, 5, 6, 2. And this is from the last drawing. They were there. Now they want me to move point E, which in the last one, E was at 4, 4, but this time they want me to move it to 7, 5. 1, 2, 3, 4, 6, 7, 1, 2, 3, 4, 5. I think I'm about right there. Wow, hitting everything wrong today. Okay, so here's my new figure, and it says, what type of quadrilateral is this, okay? I'm going to guess, I mean, I don't know. It could be a trapezoid, depends what my slopes are, basically. So let's go ahead and count the slopes, okay? You're welcome to use the slope formula if you find that more accurate, especially if you think, I'm not a good artist and my sketch isn't great, which could be very true. Okay, so from C to D, I'm going to count up 1, 2, 3 to the right 1. So up 3, right 1. That's my slope. From D to E, I'm going to count up 1, 2, and go over 1, 2, 3, 4, 5, 6. I think I'm over 6. Does that sound right? So up 2 over 6, which reduces to 1/3. Okay, from F to E, I count up 1, 2, 3, and right 1. And from C to F, I count up 2 and over 1, 2, 3, 4, 5, 6, which reduces to 1/3. All right, I notice I have opposite sides parallel and opposite sides parallel. All right, if I have 2 pairs of opposite sides parallel, I cannot have a trapezoid. So because both, right, both opposite sides are parallel, I have a parallelogram. And all my rules from today with the trapezoid would not hold true because I have 2 pairs of opposite sides parallel and I only want 1. All right, finding angles here in this trapezoid. So super important as we look at this trapezoid, we realize the legs are congruent. which means I have an isosceles trapezoid. So that means base angles are congruent. So angle C down here has to be 135 to match angle B because they touch the same base. All right, to find my other angles, I know between bases, these angles equal 180. So if I do 180 minus 135, I get 45 degrees. So that means angle A has to be 45. And again, base angles are congruent, so angle D will also be 45. So the measure of angle A is 45, and the measure of angle D is 45. I do get matching angles on an isosceles trapezoid, but not necessarily on a regular trapezoid. In fact, I won't on a regular trapezoid. All right, next page. Let's talk about mid-segments of a trapezoid, okay? And again, if you can recall way back from chapter 5, mid-segments of a triangle, you're going to start saying, wait, I think this is like really familiar. I remember hearing these same words. So the mid-segment of a trapezoid right here is going to be parallel to each base, okay? Similar to our mid-segments of a triangle, we're parallel to this opposite side. So the mid-segment is parallel to each base, and its length is 1/2 of the sum of the bases. So MN here was parallel to AB and parallel to CD, and it's going to be half of its bases, AB plus CD. If you recall from chapter 5, the mid-segment of a triangle was parallel to its opposite side and half the length of its opposite side. Kind of coming back, but we have more things here. So one more thing. So the mid-segment of a trapezoid is parallel to the bases. I shouldn't say one more thing. I'm just going to write it one more way. And it's going to be equal to 1/2 of base 1 plus base 2, okay? So the mid-segment equals 1/2 of base 1 plus base 2. It's kind of a formula for us. We're going to use that often to find it. Sometimes we kind of do it mentally, but if we have to work backwards, we need that formula or that equation or that setup to keep us organized. So in this diagram here in example 3, it says MN is the midsegment, and I can tell because M's a midpoint and N is a midpoint, and joining midpoints, we call that a midsegment. So MN is the midsegment, and we want to find its length. So the length of a midsegment equals half of, I'm going to just put base 1 plus base 2 just to kind of remind us. Does it matter which one is base 1 and base 2? No, not at all, as long as we know there's two different bases. So let's see. I have a base of 16. I have a base of 9. 16 plus 9 is 25. Half of 25, 12.5. Okay, so there's my mid-segment because it's half of that length. All right, moving on here to the bottom. Find this MN, which once again, when I look, I can see that M's a midpoint, N's a midpoint, so I know that MN is a mid-segment, right? If they join midpoints, they're mid-segments. So right away, I'm going to write down mid-segment is 1/2 of base 1 plus base 2. All right, I'm looking for MN, my mid-segment, and it's going to be half of one of the bases is 30 over here. The other base is 12 over here. 30 plus 12 is 42, and half of 42 is 21. So my mid-segment on this one is 21. All right, we're just flying through these pages. Let's go to the next page. Moving on to kites. If a quadrilateral is a kite, and remember, just a quick reminder here, on a kite, the rule is sides that touch each other are equal, but opposite sides cannot be equal, okay? So on this kite now, the diagonals are perpendicular. I remember that one from rhombus. All right, so get perpendicular there. BD, it's one of the diagonals, and CA in the middle there, those are perpendicular. So in this kite, my diagonals are perpendicular, and my drawing is terrible. Quick question, if you ever made a kite, did you stick two sticks together and kind of try to join them in a perpendicular, and then you covered them with paper maybe? So it kind of fits that idea of how you make a kite, and that's how a property of every good kite. Okay. Second one, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. One pair of opposite angles are congruent. Okay, so angle A and angle C are congruent, but angle B and angle D are not congruent. Only one pair can be congruent, okay? So over here, one pair of angles is congruent. Okay, I want to kind of add just a little thing. The congruent angles touch non-congruent sides, okay? Do you see how I have a 1 mark and a 1 mark, and then a 2 mark and a 2 mark? That's where my congruent angles have to be between the sides that are not congruent. Okay. So let's see what we have here. It says find angle T in the kite shown at the right. Okay. Notice my congruent markings. Okay. I have these two sides here are congruent. These two sides here are congruent. Opposite sides are not congruent. So once again, if I know I have one pair of sides congruent, I know I have to go between the non-congruent sides and find an angle. Between the non-congruent sides and find an angle. Those are my two angles that are congruent, okay? So there's exactly one pair of congruent opposite angles. Q and S obviously already are not congruent, and so that's another quite indicator that R and T have to be congruent. Okay, so we know R and T are congruent, so I'm going to make them X and X. What do all angles in a quadrilateral add up to? 360. Okay, so I know I get this 360. So my T and my R are X and X. I can add my 70 and my, is that an 88, I believe, for the other two. Okay, so X plus X, I guess I probably could have written the names, probably is what they wanted there, and I didn't do that. All right, X plus X is 2X. Okay, 70 plus 88 is 158. Subtract 158, I get 2x equals 202. Divide by 2, and x equals 101, which means angle T equals 101 and angle R equals 101, okay? You will always have one pair of angles congruent in a kite. Not necessarily in a trapezoid, but always in a kite. All right, another quick one here. Find the measure of angle G in this kite shown at the right. So I notice my two pairs of congruent sides, and in between the non-congruent sides are angles that have to be congruent. So angle G has to equal angle I guess it is. I'm going to put X on both of them. So I get an X plus 85 plus 75 equals my 360. So 2x plus 160 equals 360. 2x equals 200, and x equals 100. So the measure of angle G is going to be 100, and the measure of angle I, they asked me just for G, but I use that rule of opposite angles, one pair of opposite angles congruent. All right, I know we've already done 5 pages, but I don't like to waste the back of a paper. Flip that last page over. I have one more page of notes. Okay, and remember, when I add these, there's a good chance it's going to be helpful to us in a problem in our homework and a problem on our next quiz or test. So it's a good thing when we get extra problems. I have the ratio of the lengths of the bases of a trapezoid is 4 to 11, and the length of the midsegment is 15. Find the length of the bases. Okay, so a couple things here. I don't have a picture. I'm drawing a picture. I have a trapezoid. I have a midsegment, right? The length of the midsegment is 15. I have the ratio is 4 to 11. Do we remember from chapter 6 what we do with ratios? If we're given a ratio set about some kind of measurement, we put X's on those, and we put them into the picture. So like one base is 4x, one base is 11x, okay? If you're given a ratio, put that variable on it, and then put them into your picture. Now we can go through and use whatever formula or setup we know to solve for what we had. We're talking about a midsegment. And I remembered that midsegment had an kind of equation or formula that says 1/2 of base 1 plus base 2. Okay, there's my setup. It's time to plug and chug. What is my midsegment length? 15. What is one of my bases? 4x. The second base, 11x. All right. Do you like working with a half? How do I move it? I can move a half by multiplying by its reciprocal, which is 2 over 1. Same thing as 2, right? Cancels on this side, and I'm left with my 4x plus 11x. I multiply on this side. 2 times 15 is 30, divided by 1 is still 30. Over on the right, 4x and 11x make 15x. I can now divide by 15 and my x equals 2. Am I done? No, they said what's the length of the bases. So what I need to do is go plug it in. 4 times 2 on the top is going to be 8. 11 times 2 on the bottom is going to be 30. Okay. Oh my goodness, don't ask me what I just did there. How about 11 times 2 is 22? Okay, I'm going to tell you there's 30 in my brain because I want you to do a quick add your bases, base 1 plus base 2. That will make 30. Divided by 2 is 15. And you can see how my mid-segment is exactly half of my base lengths. Okay. Oh, it's a wonder you trust me sometimes. All right. I have a kite, and I'm trying to find the length of AB, and I'm trying to find the length of BC, so I have 2 of them here. All right, properties of kites, right? 2 sides are the same, so I know those 2 are the same and these 2 are the same. Still doesn't help me. Diagonals are perpendicular. When I put my right angles in, up here, I see a nice right triangle that has a 6 and an 11 and an X. And down here on the bottom, I see a nice right triangle that has a 6, a 14, and a Y. Makes Mr. Pythagoras excited, right? I have right triangles. I can solve for missing right or side lengths. So on the top triangle, I'm going to do an a squared plus b squared equals c squared. And c is the most important one to put in the right position, and that needs to be my x right there. Don't mind me and my extra symbols that seem to appear every now and then. All right, go back to my pen. That's my C. Okay, put X in there. My 11 and 6, it doesn't matter where they go as long as they're in there. 11 squared is 121, 6 squared is 36. They add together to make 157. And I didn't tell you how to leave it, which means you can go for the decimal. Square root of 157, about 12.5. Remember, if I want that in simplified radical term, I will say that, okay? So that's my AB. All right, let's go on and find my Y. Down here on the bottom triangle, another a squared plus b squared equals c squared. This time my C has to be the across from the right angle, so this time it's a Y. And I get a 6 squared and a 14 squared. Where they go, it doesn't matter. They'll get the same job done. 6 squared is 36. 14 squared is 196. Add those together, we get 232. And we take the square root, and we get about 15.2. And that's going to be my BC. Okay. So about 15.2 here, which means this side will be 15.2. And if we had 12.5 up here, then this side will also be 12.5. Okay. All right. So we have these properties. We have these things to think about. We've practiced some. You have a worksheet, I believe, on our triangles, trapezoids, and our kites. Please complete the whole worksheet, all the problems on it. And if you have any questions, please let me know.